to Vicky Liu, our chair for the Committee of the Environment.
So thank you, Yimei, for the introductions. Well, climate change is getting increasingly urgent, and you don't need to be an architect to know the urgency of it. So this year at AI Hong Kong, we just established called Committee of the Environment. And although the committee is new in our chapter, it has a history of 33 years in the AIA. Before there are LEED or ESG, and before sustainability was a buzzword. And Yimei and I just got back from San Francisco, where we attended our AIA National Convention. And let me share a few things that we are doing at a national level. If you haven't checked out the AIA website yet, actually we have a lot of tools and resources to help you on the journey of sustainability. One of the key initiatives is the Design Excellence Framework at the AIA. It comprehensively addresses climate change and other concerns, including well-being and integration, design excellence. And sustainability at the AIA does not mean compromising design excellence. Instead, it is integral to it. And then there's the AIA 2030 commitment. Over 100 architectural and engineering firms of all sizes pledges to address carbon emission of buildings within this decade. And we hold ourselves accountable by reporting the energy and carbon impacts of the projects that we design and build. And by collecting this data, actually we know where we stand in terms of addressing the carbon emission of our building. Over the last 15 years, we as an industry have found ways to reduce operational carbon from building energy use. It is by nature of what we do as architects. So that's embodied carbon, but that's operational carbon, but embodied carbon, not so much. Actually, from the firms that we have surveyed, only 5% of the firms have been checking their embodied carbon so far. So we still have a long way to go to address the embodied carbon in our materials. And embodied carbon of material is quite complex because it entails the entire supply chains, and it also goes beyond what we do day to day as an architect. But that does not mean we don't have an impact, and that is why at AIA Hong Kong we have been hosting events about embodied carbon of materials. Just last week, we have an event with Color Living, looking at sustainable materials and also looking at hospitality as a sector, how it addresses the carbon impact in the built environment. And embodied carbon won't be addressed until we address the supply chain. Then last month, we had a visit up to the Greater Bay Area, to the Far East Facade Factory, looking at how the organization addresses embodied carbon through the manufacture stage all the way to installation at the building site. And this is taking advantage of the Greater Bay Area unique strength of manufacturing and fabrication of the building materials. And we host a series of green happy hours, like last month as well. We had this event at Quadra where we look at how the company addresses the entire supply chain from raw material extraction, manufacturing to end of life cradle to cradle, whole life cycle of the acoustic panels. And as architects and designers, we work project to project. And at AIA, we believe this is our ultimate project. Which brings us to today. We are rediscovering bamboo as a low carbon materials. But this is happening in an overarching context of why embodied carbon material is very important. So let me introduce our two speakers. Our first speakers will be Grace Kwok, founder and managing director of Allied Environment Consultants. If you are working on projects in Hong Kong, you probably have collaborated with her firms already. So first, Grace will give us an overarching view of why embodied materials is important and what are the policy and standards out there that help us to address its impact. And then our second speaker will be Alex Choi, Managing Director of Bamboo International. Alex himself came from a strong background in real estate, and he is now focusing promoting bamboo as an emerging material, from structural bamboo to bamboo finishes. So this will be an exciting section for all of us. And next, I'm going to pass our presentation to Grace. So Grace, you can share screen.
Hello, everyone. Good afternoon. Thank you, Yimei and Vicky, for the introduction. So thanks for having me at this webinar. And at the top of the topic of my talk is material diet, strategies to reduce embodied carbon. So what is material diet? Material diet is about how we could choose the material wisely in order to reduce embodied carbon. And then, in fact, it talked about it a bit like, the diet we'll use when we're trying to keep fit. So it's also talked about a material pyramid in a way that conventionally, I think we use more high carbon construction material, and then now starting to have a bit more low carbon material. But there's also choices of climate negative material that we could use. So if we, swap the weights, the proportion of this kind of material we use to choose more bio-based, including timber or bamboo-based material, then we could, have to compensate for the higher embodied carbon emission from those conventional construction material, and in order to achieve a climate neutral composition. And that is what the researcher called material diet. So this is the table of contents of my sharing. So I touch on whole life carbon assessment, and also because of ESG, the real estate sector is also looking at GHG emission accounting, and also some latest trend in green building industry and ESG, and the approach we're using now to address life cycle impact of building material. And lastly, a case study on construction stage carbon management we are currently doing in Hong Kong. So whole life carbon assessment, I think in one of Vicky's slides, she also showed us that in a few years' time, maybe right after 2030, the amount of embodied carbon in the whole life cycle impact of a building will be more than that of operational carbon. And that is because the operational carbon is going to be largely reduced because of the use of new energy, more renewable energy, and also decarbonization of the electricity consumption. So in a lot of countries, in fact, they're looking at zero carbon electricity generation after 2030. So it is important for us to focus in ways to reduce the embodied carbon. And what is whole life carbon assessment? So from a life cycle assessment perspective, it is about managing the carbon emission from different stages over a building's life cycle. So in the table shown in the right-hand side, you could see in the building's life cycle, we look at product, procure, in use stage, and end of life. So during the construction stage is more about the product and procurement stage. So the carbon emission from raw material to the transport to manufacturing unit and manufacturing emission. In fact, we'll call it cradle to gate. And if we include transport to site and work on site, that will be cradle to site. So from A1 to A5 on this life cycle LCA assessment. And then from A1 in fact, we're looking at all kinds of material used in construction project, including rebar, concrete, metal, wood, etc. And for A2 is about transport to manufacturing units. So it's the carbon emission from the transport of raw materials to the production plant. And then the manufacturing process, carbon emission is covered in A3. So after the construction materials been manufactured, we need to transport it to site, and the carbon emission from that part is covered in A4. So to reduce embodied carbon emission, we encourage the use of materials produced regionally, and locally is even more preferred to reduce the environmental impact arising from transportation. So how we define regional material? Actually, it's a material that are extracted, harvested, and will recover as well as manufactured within 800 kilometers from the project site. And for Hong Kong, because if you look at this map, we have, almost half of the 800 kilometers actually is in the ocean. So in fact, it does, in a way, limit the choice of regional materials that we could use. But if we are using rail transportation, it could cover up to 1,600 kilometers, or it could cover up to 4,000 kilometers if it's by sea transportation, because taking into account the amount of carbon emission from different kind of transportation method. So A5 is about work on site. So it covers fuel consumption, fresh water consumption, purchase electricity, and also waste disposal of the waste that could be generated on site. So what about greenhouse gas emission accounting for real estate sector that's been used in finance sectors and also in ESG reporting? For GHG accounting method, we are using scope 1, 2, or 3 greenhouse gas accounting method. For scope 1 is the direct direct emission of carbon emission. So that includes the fuel you're going to use in your facilities or your vehicles. And scope 2 is the indirect carbon emission, GHG emission, that include purchased good, capital good, transportation, business travel, and it's also, scope 2 is mainly the purchased electricity, but the scope 3 would include the indirect emission from upstream and downstream that cover the purchased good, the transportation, and also the end-of-life treatment of sold product. So if we're looking at construction material and also construction activity, that would be the upstream scope 3 emission from purchased goods and service from the contractor, and also the upstream transportation and distribution to the construction site. In fact, if we include the waste disposal and then the construction activity from demolition at the end of life of the building, that would also cover the end of life treatment of sold products from scope 3 downstream. So what about the latest trend in green building industry and ESG landscape related to embodied carbon? I think the most important one is the establishment of global baseline and also different reduction pathway for embodied carbon emission. So our IBA, they have set a baseline according to this table for different type of building, and also a midterm target of 30% reduction in embodied carbon by 2025 and 40% reduction of embodied carbon by 2030. And it covers school, offices, and domestic. And also LATI and London, they have also set out the target for 40% reduction of embodied carbon by 2030, 2020, and 65 reduction by 2030, with some baseline that they've set from the data they collected in UK and some European country. Another global baseline that has been recently published is the by the Science Based Target Initiative. Now, a lot of companies, they have set out their own ambition and also decarbonization target, and some of them has used the Science-Based Target Initiative to set out the target to be aligned with Paris Agreement. So this is a new set of guidance for the building sector that has been published by Science-Based Target Initiative in mid-May, which is now under consultation. So if you're interested, please check out this two set of guidance and tools on SBTI's website, and you could provide your feedback during this consultation period. I think it will be end in mid-July. Yeah, 16th of July. So one of the key proposals in the Science-Based Target Initiative building sector guidance is about the embodied emission pathway. In fact, they also have another proposal for operational carbon reduction pathway, according to the CRAM pathway. You can check it out in the two as well. So back to embodied carbon emission pathway, which is the topic of today. So they have set out some global baseline as shown in the table in the right-hand side for different type of building, residential, office, retail, and other types of building. But you could see, in fact, the target is considered quite stringent if we are using some of the embodied carbon baseline, in Asian country. So because for this global pathway and target, they have used data that they collect probably more from the European country. So in the embodied emission pathway for new building, you could say that reduction target is in fact quite ambitious. It's 97% reduction relative to a 2020 absolute greenhouse gas emission by 2050 for the embodied emissions. So what about Hong Kong? In fact, the Hong Kong Green Building Council has just published a climate change framework for built environment earlier this month. So within this framework, there's chapter about operational carbon target setting and also embodied carbon target setting. And also there's a chapter on physical climate risk assessment, and another one about climate resilience and adaptation. So you're also encouraged to check this out. This publication can be found in the HKGBC website as well. So for embodied carbon, there's a proposed certification scheme under this climate change framework to encourage industry stakeholders to set target. First is to reach 40% reduction by 2030. This is also aligned with the World Green Building Council vision. And then the target is to have zero upfront embodied carbon by 2050. So there are two approaches. First approach is a self-determined embodied carbon baseline for a project. So you could use 2 or 3 design options to compare with it. And then a consistent approach should be used for determining the baseline case and the alternative design case. And also an absolute embodied carbon baseline, which is also included in the framework. But it should be noted that the baseline for the Hong Kong Green Building Council framework only consider superstructure, as the ground conditions could vary considerably in different locations in Hong Kong. So to increase comparability of different building design, and also the baseline include A1 to A5, that is the construction phase, upfront embodied carbon, which I introduced earlier. So it does not include foundation, MEP, and non-structural elements, including internal finishes yet, but this is a living document. So we're going to see a further version and possibly including more elements, components of the building in the embodied carbon emission calculation later on. So the approach to address life cycle impact of building materials, and I think probably you have seen this chart before. So this is about the carbon reduction potential of building over its life cycle. So the highest potential comes from planning. And of course, if we could use the existing structure to reduce demolition and reuse some of the demolished material, that would give you the highest potential to reduce the embodied carbon emission. And then during the design stage, we should consider build less and build clever, to optimize the build form, the structure, to use DFMA, and also design lighter facade, etc. Reduce the MEP ductwork. Design for flexibility and deconstruction is also important, so that we could reuse some of the material and reduce demolition later on during the building life cycle, and build clever to optimize material usage and design with low carbon materials, recycle materials, and also build efficiently to use low carbon construction technology and eliminate waste. So pre-construction and prefabrication is also a method that we're using more to build efficiently. So now when we're choosing the material, when we're designing for different build form, the embodied carbon consideration should be taken early, because, you know, later on it's difficult to reduce it further. And so this should be the first thing you consider when you're designing and choosing the material. So the cement and steel, in fact, represent the highest portion of embodied carbon in buildings, especially, you know, in Hong Kong. And the cement sectors is also the third largest industry, energy consumer, and second largest GHG emitter from the industry. So it represents 5 to 8% of carbon emission globally. I'm going to talk a bit more about green concrete and green cement later on in the case study. And still, now we are using more recycled steel because it's highly reusable. So it is recycled under the circular economy model. So steel products such as rebar are produced from electric arc furnace with scrap steel, in fact, can achieve more than 80% recycled content. So the GHG, the global warming potential value of rebar is much lower than those produced from blast furnace. And aluminium in the facade, in fact, is one of the most emission-intensive manufacturing sectors. It generates 2% of all man-made GHG emission. So it is 7 times embodied energy from the primary aluminium than that of steel. So we really need to use it more cautiously, and also try to reduce the weight of it. And the mass timber and bamboo now is being used more as a way to reduce embodied carbon. And it is considered as a carbon sink and low carbon building materials and products, which offer a key mitigation option from the building sector. For some cases, it could be close to net zero or even negative carbon. It can benefit the carbon in different way. You know, the trees and bamboo, they capture and store carbon as they grow, and then some of long-lived wood or bamboo product lock in the carbon. And I think Alex is going to talk a bit more about the bamboo-based material and his sharing. So another very important trend is to specify material with requirement on environmental product declaration. So environmental product declaration is actually a standardized document. It will tell you about the product's environmental and human health impact. It is based on an ISO standard, the ISO 14025 standard. So it is a scientific footprint method using the life cycle assessment. So first, you need to conduct a life cycle assessment before you can have all the data to be included in the EPD. So it will tell you about the product's environmental impacts for so that you could choose the different product carefully. And this is an example of an EPD. So you can see in the EPD, there will be, the system diagram of how the product is produced, the module that is covered in this EPD. So you could see for this particular product, this is a solid wall precast concrete. It covered the product stage from raw material supply to transport, manufacturing, and also the transport to the construction site, and also end of life usage, including deconstruction, transport to the waste processing and disposal, as well as reuse and recovery of a potential of this material. You have the content of the material and also different indicators showing the environmental impact of this material. So I would like to highlight, in the right-hand side, the bottom table. Usually in the EPD, we'll use the global warming potential to show the carbon footprint of the material. And it's also important to note that, for material having an EPD doesn't mean that it would be low in embodied carbon emission. You need to check out those values and to compare, among different products to choose one that can meet, your requirement for embodied carbon limit. And there's also different tool that is available for you to estimate the building life cycle carbon emission. In Hong Kong, we have the CIC carbon assessment tool, but there's also international embodied carbon assessment tool available. But it is important to note, the module that they cover, whether they include all the stages or just some of the stages, like for the CIC carbon assessment tool, it include from stage 1, A1 to A5, but it may not cover some of the fit-out material. But in other tools, they may cover more materials related to interior design and fit-out. So now another important move is to conduct construction stage carbon management as part of the life cycle assessment. Because before, when we focus more on the operational carbon, I think in a lot of projects, we would conduct building energy simulation to find out, the operational carbon emission of that building under different design scenario. But now we also need to find out the embodied carbon emission from different building design and choice of materials. So we would conduct preliminary embodied carbon assessment based on the preliminary design, and also development of carbon management plan, such as setting different KPI for the target embodied carbon, and to develop construction materials specification and recommend emission factors for building materials. Embodied carbon tracking during the construction is also very important to review the emission factors of the construction material used, and keep track of the emission and propose action or measures if necessary. And the final embodied carbon assessment to verify the embodied carbon assessment at the end of construction stage, and also to review the actual embodied carbon emission against target. This is important for us, to learn from each project and then gather the data and to have better construction stage carbon management in the next one. So this is a case study on construction stage carbon management. This project is still ongoing. So it's in Hong Kong. It is one of the redevelopment project of Grade 8 office on the Hong Kong Island side. So we have proposed some low carbon features like low carbon EAF, green rebar steel, and use green concrete and cement mixed with cement substitute, use biodiesel on site, construction site electrification, and comprehensive site practices for waste management. So you can see on the right-hand side, on the top is the baseline case, and then on the bottom is a design case. So we are targeting to achieve about 50% of embodied carbon reduction for this project. So for green rebar and steel, in fact, this is now the largest driver in achieving low carbon emission using high recycled content and switching to electric arc furnace. So comparing to a typical rebar, the carbon footprint can be reduced by 40 to 50%. In this case, we are also using regionally manufactured green rebar. And the reason is I showed the two products on the top right-hand side. In fact, the rebar from Turkey has a higher recycled content, but you could see the CFP value, the carbon emission, in fact, is higher than the one manufactured in Singapore, though the one in Singapore has a lower recycled content. The reason is because of the transportation carbon emission. So green concrete, for this, we're using PFA up to 25 to 30% cement replacement and GGBS and also silica fume in order to reduce the embodied carbon from the concrete, and also the low carbon cement will be regionally sourced, and also the cement manufacturer with clear net zero strategy and roadmap, and other low carbon construction practices like using biodiesel, early planning and contact with utility company so that we could use electricity on site as soon as possible, and as when we start the construction, and also good waste sorting, recycling practice to increase waste recycling, and carbon tracking and reporting to review the actual embodied carbon emission. So lastly, a bit about AEC Group. So our company is Hong Kong-based, pioneering sustainability and environmental consulting firm with more than 29 years of experience. So we have 5 segments: green and healthy building, environmental consultancy and sustainable design, acoustic, audiovisual, lighting, and theater design, and green finance, sustainability and ESG advisory, as well as smart and green IoT. In fact, we are now working with a client on both project and also the organization level to achieve carbon neutrality and to enhance climate resilience. So if you're interested, you could check out our website. And also there's a film about green building that we have made before together with BBC and World Green Building Council. So thank you very much.
So thank you so much, Grace. It's very informative with a lot of scientific and relevant information to our practice in Hong Kong, Greater Bay Area, and Asia. So you might, our audience might have questions for Grace, but let's save it a little bit later for our panel discussion. Start typing in the questions in the Q&A box. And our next speaker is Alex. Alex is Managing Director of Bamboo International. Some of you might have attended his lecture last year talking about structural bamboos from a scientific and technical perspective, but today he's come back with some new content to share with us. So Alex, start sharing screen and share with us your presentation today.
Hi, good afternoon. Thank you for the opportunity to speak here this afternoon. Thank you, May, and thank you for the introduction. And it's a great presentation by Grace on embodied carbon. I will focus to talk about bamboo in today's presentation. I chose to start in the bamboo business about more than 4 years ago. I think the reason is, in addition to bamboo being its benefit to the environment, because bamboo industry on its own is a poverty relief initiative in countries including China and most Southeast Asian countries. I believe it's a win-win endeavor both environmentally and socially. So that's why we are keen to see how we could promote bamboo's application generally in the building sector. A brief introduction about us, Bamboo International Limited, BIL. We have different business lines in addition to the more traditional design delivery services of building material. We also have other business lines through joint venture with different entities, because we believe that to promote bamboo, I think we really need to spend resources and time on research to really dig out all the hidden benefit of bamboo as a material. And we also would try to integrate bamboo with other green technology to form a more integrated green solutions to offer to the market. So that's where we are. This is the content of my presentation today. About the embodied carbon emission, I think Grace has talked a lot about it, and I have no intention to go into any detail on that. And I can only say that tackling embodied carbon is gaining momentum internationally, is becoming one of the biggest topic in the building industry. And here are some examples of important government initiative in Europe and in China. In Europe, the European Parliament has passed two key initiatives beginning of this year. It set out clear initiative and clear target for the member state to follow. They try to set out more definitive target to be achieved in terms of embodied carbon, and also they want to unify the methodology to be applied in EU. I think that would go a long way to encourage the building sector to put more emphasis on tackling embodied carbon. And also we believe that would also drive industry to have more innovation to explore new low carbon materials, not just bamboo, but other low carbon materials to be used in the market. And China actually is actually moving faster. Back in 2022, they have passed two policies to encourage the procurement and the application of low embodied carbon building materials in the country. And in the same year, and I think the year before, in the consideration of low embodied carbon building material, China has earmarked bamboo as one of the key building material they want to pursue. I think the reasons are, one is China has rich resources in bamboo, and second, as I mentioned earlier, bamboo industry actually is a very important poverty relief initiative for the Chinese government to take care of all the farmers in the country. So they are moving really going ahead in promotion of building bamboo in the market, and hopefully Hong Kong can follow quickly along this line of direction. Now, the benefits of bamboo, I think we all know that the benefit of bamboo as a natural material is a renewable material resources, and is benefit to the environment, including soil health, and of course the carbon sink property. I'm not going to go into detail of all the small numbers, but I think we are all aware of this environmental benefit in natural bamboo. And I would turn to engineering bamboo, which is normally what we use in the building sector. Generally, now there are two types of engineering bamboo. One is what we call the solid bamboo. It's basically a laminated product hot pressed using glue. And the other is what we call the strand woven. It is formed by high pressure press of bamboo strips in a more fibrous form. They have different pros and cons and different applications. Solid bamboo generally are more versatile and flexible, and it can be basically turned into various profile of a big range of design aspiration, which I will show later in the slides. And strand woven bamboo is it's a later technology. The key reason for the strand woven bamboo being is it is much more hard and robust, and it's more suitable for environment, for location of heavy traffic, especially say flooring in outdoor and say high traffic environment, say in a train station. And look at the table below, you can have a very high level comparison between the physical properties between engineering bamboo and timber. And you can notice that engineering bamboo in terms of physical properties is at least matching, if not better, than timber that we're normally using in the building industry. And these slides are following some examples about the application of engineering bamboo, which is actually by our company. In Hong Kong, it's mostly as a filler material. The top right-hand side is the Shaw Auditorium in Hong Kong USD. Below is M+ Museum. In the middle is a Kowloon East Regional Police Headquarters. And on the right-hand side is the Hang Seng University in Sha Tin. And the next slide is about some structural bamboo that we undertook in China. It is true that internationally, including China, there isn't any regulatory regulations on structural bamboo. Only recently, ISO has passed, has released new regulation to look at structural bamboo. But the Chinese government is more open to embrace a more engineering approach to use structural bamboo in different settings. Here are the projects that we have been doing in China. And it can show that we're seeing a lot of mass timber structural buildings in the US and in Europe. And we, based on experience, structural bamboo can actually achieve very, very similar results. And this further shows the versatility of engineering bamboo. It can be shaped and formed into very different form of shapes, and even small accessory on the top right-hand corner. So it's very high flexibility and agility in terms of it as a building material. Furniture is bamboo furniture is actually becoming very popular in the US and Europe, not in Hong Kong, but overseas is becoming a very, very promising market. And durability is a question that most people will ask about engineering bamboo. This is a project that we did about 10 years ago in Shanghai. It's a restaurant. The building facade is bamboo panel. Now it's 10 years on. I took these pictures earlier this year. There hasn't been any really aggressive maintenance or replacement in the 10 years. And you can see that the bamboo panels are still in a very decent condition that actually shed some light about the question about the durability of engineering bamboo in external environment. Shanghai is actually quite wet and humid, similar to Hong Kong. So that should give us more confidence when we try to consider bamboo as a facade material. This is in Hong Kong, the Hang Seng University. The deck also completed 10 years ago. Because it's deck is more frequently used, more regular maintenance will be required. But I think the key issue in here is, yes, there is color fading as a result of radiation, but we are not seeing any substantial structural defects or damage in the past 10 years. This is a research paper in one of the researchers in Europe. They're talking about a material diet. Grace has covered that, but this is a very paper I think worth reading. It set out a very comprehensive analysis on the life cycle assessment of different material, cement-based, timber-based, and bamboo-based, and to look at the potential benefit of the different material in the pursuit of carbon neutral buildings. And this is a study that we commissioned a professor in the City University to help to prepare for us. We are using the actual manufacturing process of our own factory to carry out a life cycle assessment, and we compare that to the other more commonly building material available in the market. When we look at the left-hand side, the green, the pink, and the red figures, they are based on different end-of-life treatment of the bamboo. In Hong Kong, we really don't have any real end-of-life treatment of any bio-based material. Basically, end up in the landfill. But even given that, you can see that the embodied carbon of bamboo, this is based on cradle to gate, the factory gate, not including the transportation from the factory to the final site destination. You can see that the embodied carbon is basically very close to neutral. And if you take into account active end-of-life treatment of the bio-based materials, say we use it as a bio-based fuel, in place of fossil fuel for energy generation. The combined embodied carbon actually is negative because of the carbon saving, the carbon credit gain to consume the bamboo at the end of the life as bio-based fuel material. So it is a very encouraging sign, and we try to capture the numbers in a more quantitative manner. Now, looking into the future, so what can we do more to promote bamboo, in our opinion? As I said, despite bamboo has been used quite extensively in the US and Europe, and the robust physical properties of engineered bamboo is well tested and documented, it is still not one of the mainstream material that that stakeholders in Hong Kong will want to consider, including the government, private developers, facility manager well-being. Actually, Architect Friends has been helping to promote bamboo in many occasions, and at the end, the final developer, the facility manager, and others are actually quite conservative, and we are seeing a lot of roadblocks along this direction. But hopefully that will change. The mindset will change going forward. And one of the things that we believe could actually help to promote bamboo is the regulatory framework. There isn't any regulatory framework. There isn't any requirement on the assessment of embodied carbon in Hong Kong. And so that actually is one of the key barriers in the onward promotion of bamboo in Hong Kong. Hopefully the situation will change. And there are few things that I would want to suggest that going forward in the promotion of low embodied carbon material. Mentioned earlier by Grace is Hong Kong GB's, Hong Kong Green Building Council is passing a new framework on embodied carbon. And we hopefully the government also will respond to that to include embodied carbon in the Hong Kong Climate Action Plan 2050. It's quite disappointing that this is not even mentioned in the Hong Kong Climate Action Plan 2050. Hopefully the government will revisit this and borrow the experience from Europe and from China to really focus to gather the resources in Hong Kong to tackle this issue. This is the same report I mentioned earlier that we commissioned the City University's professor to carry for us. We were trying to quantify what will be the potential benefit if engineered bamboo is used more extensively in Hong Kong. So this is a very interesting scenario. We try to replace the wood stock in Hong Kong by engineered bamboo, and we look at the carbon saving as a result. The two you can see that the two numbers in here. One is as is the business as usual case. That means there isn't really end of life treatment of the bamboo, but you can still see a very significant improvement in embodied carbon. If Hong Kong has also the end of life treatment as in other parts of the world, the embodied carbon mitigation benefit can actually be very substantial, up to almost 25% of the total carbon emission in Hong Kong in the year 2020. So this is I believe this is a very good tangible presentation of the real benefit of low embodied carbon material, including bamboo. The other is, as I mentioned earlier, we would like to have more government support in research and development in bio-based low-emission carbon material. We have been working with City University on material research, and this is our first research product. We call it Super Bamboo, and receive Gold Award in a Geneva conference on innovation. And we have the US and Hong Kong patent already. And this Super Bamboo, what we call Super Bamboo actually is that there are two benefits in here, in this material. One, it is, we structure the bamboo material in a way that we do not need glue to form the final product. As I mentioned earlier, from raw bamboo to engineered bamboo, glue has to be used to make sure that the structure is there to form the structure that we need for the building, for the eventual end building products. But in this particular invention, we have to discover a way to rearrange the bamboo material that we do not need glue to form the final product. So that is the, if you like, the greenest building material that we can look for. And second, because it's highly densified, it is very strong and it has the potential as a very robust structural material, replacing the high embodied carbon, the traditional high embodied carbon building structural materials, say in steel, metal, or in concrete. And I think there's another benefit we mentioned earlier when we look at the embodied carbon of building material. We actually have to look at the longevity of the building element. Now, bamboo and most other bio-based material are being used mostly as a filler material. Now, the filler material has a relatively short life. When it is demolished, and in places like Hong Kong, it would only end up in a landfill. And the carbon stored in the building product will be released back to the atmosphere, which is not something that we want to see. So if we can extend the longevity of the building product, meaning the carbon will store in the building products for a much longer period of time, say, I mean, compare between structural products to filler material, it can easily, you can extend the life from what, 5-10 years to 50 years or even longer. So I think that's why I'm always want to emphasize that it's always a scenario of innovation and carbon neutral win-win. We can always, there's always room to take out the more value in bamboo and other bio-based material to make it a more ready alternative to all the conventional building material. I'm not sure you're all aware, bamboo basically is a grass family. That means first, there's no regulatory barrier against planting bamboo in Hong Kong. And second, it grows very quickly, one of the fast growing plants. And it has a very robust root system, meaning that it can be used to tackle a poor soil condition, and even as a root barrier. And when we look at Hong Kong, despite what we always talk about the high density in Hong Kong, but actually the built area, percentage of the built area in Hong Kong is actually quite low. And there's a very extensive area in Hong Kong where we can actually encourage the planting of more natural bamboo. I mean, it definitely will help to improve the air quality in our city. And hopefully we also would want to see that it can restore some of the degraded land in the new territories. And as a member of the Federation of Hong Kong Industries, we are asking for a meeting with the Environmental Bureau sometime later this year. One of the topics in the agenda is to discuss the possibility of setting up a public-private collaboration task force to see how we could learn from the experience, learn from the regulation from other parts of the world, to revisit some of the regulations, rules in Hong Kong to encourage or to allow the possibility of using more bio-based material in this city. Hopefully, we can get going. We can really we have embrace a more open attitude with more to really look at it just from technical merit to see how we could encourage bio-based material, more bio-based material to be used in here, which I'm sure that will help to reduce embodied carbon in Hong Kong as a whole. And lastly, there is an initiative we and our partners has been looking at in the past 12 months. Is now China has been moving very quickly in the encouragement of bamboo industries in the country. Now we are looking at it from another perspective. Is given Hong Kong's status as an international city and the availability of other resources and talent here, we are trying to establish what we call a demonstration bamboo hub in Hong Kong to show to Chinese, the other parts of the world with rich bamboo resources, how we could have a complete bamboo industrial chain established from planting, research, to industrial production, to produce real high value building products, to upgrade the current bamboo industries in China and other parts of Southeast Asia countries. And we believe this will be a very promising initiative to put Hong Kong in a more pivotal role in the regional bamboo and actually carbon offset market. So I think that is something that we will want to push on, and hopefully we can share more of that later when we are really making some, headroll into this particular project. It's really exciting. So I think that brings to the end of my presentation today. Thank you again, Yimei and Vicky for the opportunity.
Thank you so much, Alex and Grace. Hey, so Vicky, shall we start with the Q&A session?
Okay, absolutely. So we already got a few questions from our online audience. So the first question is, are there any treatment recommended to apply bamboo if we use it for outdoor area? So like just now in the presentation, Alice and Grace talked about the policy technical background. So maybe you can share with us how it is being used in practice, say for outdoor.
Yes, because the bamboo and other wood material has been used quite extensively in Europe, there has been new industrial products along this direction. We're now testing on a new prime and coating system to improve the behavior of bamboo in long term in terms of durability and stability in terms of the appearance. We have been doing that for the past 12 months. We have been doing a new experiment along the Dongchong waterfront of using this new primer system. The result has been very encouraging. So bamboo as a natural material, it actually is susceptible to mold and other natural degradation. But with the new primer and coating system, actually it is quite promising. I mean, when we look at our project in Shanghai, even without this new primer system, the result is quite good already. And I think now with the new coating system available, the durability can actually be further improved.
But that's very interesting. You mentioned this project is on the waterfront. So are there any, and it entails special treatment, special primer to
yes,
to combat the humidity. So can you share with us a little bit about how they work?
Now, this is only a very small piece of trial project along the Dongchong Promenade. We're doing just a very short, a few pieces of bamboo handrail over there. So as I said, we treat the bamboo in the factory and then we apply the new primer system to improve the durability. Is the first we first complete in last October, I believe. Now it's 8 months, and when I visited in a while ago, it actually looked as new, as the same as when we first installed it. So I believe the new coating system actually is way better than before. Even I mean in the past, when we look at our projects, is actually doing quite well. I mean, all the structural bamboo projects in China we've been doing in the past 4 or 5 years, they're still looking very good. I mean, we're not seeing any major issues, any mold issues on the outside.
Oh, that's interesting. So like since bamboo application is a rather new material, so how do you convince the client to give it a try?
So I think what happened is we will try to answer the questions, answer their concerns. We will try to understand their concern in terms of maintenance, in terms of durability, and we will try to address all these concerns, sometimes through demonstration, sometimes through test certificate. I mean, in one occasion, we work with a developer in Hong Kong. They are considering to use the bamboo material in their lobby. And one question asked by the facility manager is, our cleaning lady, they will use the one mixed with 99% of the bleach to clean the wall on a daily basis. So would your bamboo, be affected as a result? And we said no, but that is not convincing. So that's why afterwards we carry out a test based on an ISO standard that we test the behavior of the bamboo material exposed to a 2018 mixture of cleaning bleach, and the result has been good. And we show them the certificate, and then we get the project. So I think it is more hopefully they can start to think about that, and then we will try to answer all the concerns. We understand that in Hong Kong, it is a relatively new material. So we're trying to see, hopefully they have a more open mindset. They can ask us questions, and then we will, I'm confident we can give them all the answers, because it's not a new material say in the US and Europe. So it's not as new, but it's in this area, this city, yes, it's new. We will all understand it.
Well, that's very true. Actually, I've used bamboo in the first project I ever worked at as an architect. But that's in the States. Well, okay, let's move on to the second question. So we got a question from Thomas Smith, our former EXCO member. So from Thomas, I'm quite interested in bamboo as a building material, but there's often fire-resistant issues. So has Alex made any progress in improving the fire resistance of the engineered products?
The answer is no. I mean, in Hong Kong, there's a standard called the British Standard 476 Part 4 non-combustibility. I can share with everybody in today's sessions, no bio-based material can pass that test. So if the requirement is Part 4, no bio-based material can satisfy that requirement. But I think the issue is bamboo and other mass timber has been used, say, in the US and Europe as structure. So are we suggesting that they do not take that as a serious fire hazard? And why they can allow that to happen? Because there is a different standard in US, a different ASTM standard to govern the performance of building material in a fire situation. And that is a very different approach to the British standard. And I believe at least we are not hearing any real issue in terms of performance of the mass timber projects in the US, that it has caused real fire hazard in a fire situation. So I think it's, as I said in my presentation, we need to look at it from a technical merit perspective. So if this type of bio-based material has been used as structure in other parts of the world, they pass their local fire standard. So can we look at that? So yes, Hong Kong may have a unique situation that we need, certain requirement, but I'm not sure we're looking at that from that perspective. So I think that is a question that we need to answer. And hopefully in our forthcoming meeting under the Federal Hong Kong Industries with the Environmental Bureau, we can have make some headway into trying to have some kind of collaboration in encouraging bio-based materials in Hong Kong, not just bamboo, but wood and other bio-based material.
Well, that's wonderful. So the next question is also specific to Hong Kong, from Thomas. So I'm also curious about the current bamboo scaffolding situation in Hong Kong. When the bamboo members are past the end of a useful life, how are they currently being disposed of? And could the government help in requiring a higher level of recycling or reuse? So Alice and Grace can both address that.
I'm not familiar with bamboo scaffolding, so I don't know. But as far as I know, Grace I think Grace knows a bit more. I'm not sure there's any real end-of-life treatment for any building material, bio-based material in Hong Kong.
Okay, maybe share a bit about some potential more environmental friendly way to dispose of bio-based material, especially for bamboo. In fact, I think in Hong Kong, we have also built the first, we have set up the first biochar plant. In fact, bamboo is a great material for producing biochar. So, when is going to be, instead of dispose of the bamboo, in fact, it could be used to make another material, and the biochar is charcoal-like carbon product. So you can make it when you are heating a biomass, in an oxygen deficient environment. In fact, biochar has been used in agriculture for quite a long time, and also used in water and air quality filtration in the form of activated carbon. But it is also recognized as a carbon sequestration strategy because you lock in the carbon in the biochar. Is recognized by the UN IPCC as well as this part of this strategy. And also recently there are more research of trying to use biochar as part of the components in energy storage device. So I think if we're looking at more sustainable way to handle dispose of the bamboo, I think making it into a biochar would be the best way to treat it. Thank you.
Well, that's a wonderful idea. So then we can actually reuse the bamboo scaffolding cradle to cradle. So another question coming from Hisham Youssef. Can you explain more about the embodied carbon in engineered bamboo compared to engineered timber? And it seems bamboo would exceed timber because of the preparatory work to break down the bamboo. So is that the case? And what did you find out from the life cycle assessment study?
When we carried out the assessment last time, our focus is in engineering bamboo using our own manufacturing process in the factory. The numbers that we use in the comparison chart on timber and other building material, actually these are more published data that we can get from other research, internet information. So we haven't done a really direct like-to-like comparison between engineering bamboo and mass timber used in the building sectors.
Well, so I'm curious, like besides your collaboration with the City University in Hong Kong, are there other research institutes, maybe around the world, that is also that has also done significant work on bamboo studies?
I'm sure there's an organization called International Network of Timber and Rattan. Is interstate organization organized under UN Charter. They have extensive research and collaboration between member states, mostly bamboo-rich countries. They have the headquarters in Beijing. If you want to visit the website on INBA, you can see a lot of different research being carried out. Now, currently, we are all becoming more excited in using timber, using bamboo as a structural material. We are collaborating with INBA to actually carry out on-site the carbon footprint assessment in relocation of our own office, which is the timber bamboo structure, to a new location. So they want to study the kind of the real carbon footprint if we relocate one bamboo structure from location to another location. So there are actually quite a lot of effort, and I know that they have recently organized a task force to try to prepare more detailed specifications on structural bamboo, which include engineering bamboo and also include the natural bamboo pole. So they actually, in different parts of the world, there are quite a lot of research being carried out to try to look at the material, try to bring out more hidden benefit that the material can offer to us.
Well, that's great. So keep us posted of your study. So we will be interested to find out.
Well, certainly will.
This part of project. So and then another question coming online. This is not structural, but is bamboo good for flooring? So probably like
I think the simple answer is simple answer is yes. I can share with you is the bamboo industry in China was first started as a bamboo flooring material exported to Europe. So it all started as very simple, basic bamboo flooring. Now is becoming more mature. Now we can do a lot of different bamboo products. We are trying to follow the trend of mass timber to do all sorts of different products, including structure. But bamboo flooring is where we all started about 30 years ago in China.
So how is